Hello students, myself Henasha, Assistant Professor at LG Institutes of Engineering and Technology. So today we are going to discuss few more topics of indeterminate forms. So let us discuss the topic indeterminate forms of the type infinity by infinity. Problems under this type are also solved by using our L'Hopital's rule, considering the fact that limit x tends to a f of x is equal to infinite and limit x tends to a g of x is equal to infinite. Then limit x tends to a f of x upon g of x will be equal to limit x tends to a f dash of x upon g dash of x. Here again we are applying our L'Hopital's rule, that is we will do the derivative of numerator and denominator separately. Right? So let us solve one example based on this. We have to evaluate limit x tends to pi by 2 log x minus pi by 2 upon 10x. So let us start the solution. Firstly, we will assume this limit as L. Now suppose if you put x is equal to pi by 2 in numerator and denominator, what you will get? Log 0 upon 10 pi by 2, which gives us infinity by infinity form. So we will apply L'Hopital's rule. So on applying it, we will get derivative of log x minus pi by 2 will be equal to 1 upon x minus pi by 2 and derivative of 10x will be equal to sec square x. Now we will simplify this. So in simplifying, we will get limit x tends to pi by 2, take this sec in the numerator. So 1 upon sec square will be cos square upon x minus pi by 2. Now suppose if you put x is equal to pi by 2, we know cos pi by 2 will be equal to 0 and pi by 2 minus pi by 2 will be also 0. So we are getting 0 by 0 form. Now again apply our L'Hopital's rule. So what you will get? Do the derivative of numerator first. So 2 cos x. Now apply chain rule. So derivative of cos will be minus sin x. And derivative of denominator will be 1 and derivative of pi by 2, that is equal to 0. So we are getting finally limit x tends to pi by 2, 2 cos x into minus sin x upon 1. Now put x is equal to pi by 2. So answer will be equal to 0 because the value of cos pi by 2, that is 0. So final answer of the limit is 0. Now let us solve one more example. Here we have to prove that limit x tends to infinity 1 square plus 2 square plus 3 square plus and so on x square upon x cube is equal to 1 upon 3. Let us start its solution. Firstly, we will begin with LHS, that is equal to limit x tends to infinity 1 square plus 2 square plus 3 square plus and so on x square upon x cube. Now in the numerator, we will use our formula, that is sigma n square, that will give us x into x plus 1 into 2x plus 1 upon here 6x cube, because the formula is sigma n square is equal to n into n plus 1 into 2n plus 1 upon what? 6. Right? Now if you put x is equal to infinity, we are getting infinity by infinity form. Now instead of applying L'Hopital's rule, we will do some other technique. That is, we will take x common from each term. So what will happen? X into 1 plus 1 upon x. Here to take out x common. So x into 2 plus 1 upon x upon 6x cube. Now x cube gets cancelled out. And we know as limit x tends to infinity, 1 upon x goes to 0. So now finally what we will get? 1 plus 0 plus 2 plus 0 upon 6. So the final answer of the limit will be equal to 1 upon 3. Okay. Now let us solve one more example, that is we have to prove that limit x tends to infinity x raised to m upon e raised to x is equal to 0, and here our m is greater than 0. So let us start with the solution. That is, we are given LHS is equal to limit x tends to infinity x raised to m upon e raised to x. Now if you put infinity in the numerator and denominator, which form you will get? Infinity by infinity. So we have to apply our L'Hopital's rule and do the derivative of the numerator and denominator separately. So derivative of this will be equal to m into x raised to m minus 1 upon e raised to x. But again we are getting infinity by infinity form, right? So we are doing the derivative of numerator and denominator separately again. So the derivative of this will be equal to m into m minus 1 into x raised to m minus 2, and the derivative of e raised to x will be equal to e raised to x. Now similarly, we will apply the same procedure up to m minus 2 times in the above expression. So we will get limit x tends to infinity m into m minus 1, m minus 2, m minus 3. We will do the derivatives up to we get answer 1 upon the derivative of e raised to x will be e raised to x, right? Now this can be simplified as m factorial upon e raised to x. Now we know limit x tends to infinity, e raised to x will be equal to infinity, and 1 upon infinity will give us answer as what? 0. So we have proved that limit x tends to infinity x raised to m upon e raised to x will be equal to what? 0. Now let us study one more example. Here we have to prove that limit x tends to 0 log sine 2x to the base sine x is equal to 1. So let us start its solution. Firstly we will begin with LHS. So LHS is equal to limit x tends to 0 log sine 2x to the base sine x. Now we simplify this as limit x tends to 0 log sine 2x upon log sine x, right, using our formula of log. Now if you put x is equal to 0, we will get log 0 upon log 0. That will give us infinity by infinity form. So again which rule we will apply? L'Hopital's rule. So on applying it, we will simplify it by doing the derivative of numerator and denominator separately. So the derivative will be 1 upon sine 2x into derivative of sine 2x will be 2 cos 2x. Similarly, apply the rule in the denominator. So it will be 1 upon sine x and derivative of sine x will be equal to cos x. Now on simplifying, we will get 2 cos 2x, take this in the numerator, into sine x upon sine 2x into cos x. Okay. Now we will replace cos 2x by cos square x minus sine square x and sine 2x by 2 sine x cos x. Now we will cancel this sine x out, this 2 out, and now what will remain? Cos square x minus sine square x upon cos square x. Now we will separate the terms. So on separating we will get 1 minus sine square upon cos square, that will be equal to tan square x. Now we know the value of tan 0, that is equal to 0. So on substituting the limit, you will get the answer as 1. Now let us study one more indeterminate form of the type infinity minus infinity. To evaluate the limits of the type limit x tends to a f of x minus g of x, that is when limit x tends to a f of x goes to infinity and limit x tends to a g of x goes to infinity. That is, if we are getting infinite minus infinite form, we have to firstly reduce the given expression in 0 by 0 or infinity by infinity form by taking LCM or by rearranging the terms, and then only we can apply our L'Hopital's rule. So in this method, firstly we have to take LCM or rearrange the terms and convert it into 0 by 0 or infinity by infinity form and then apply our L'Hopital's rule. So let us begin by solving one example. Here we have to evaluate limit x tends to 1, 1 upon log x minus x upon x minus 1. So let us start its solution. So firstly assume L is equal to the given limit. Now if we put x tends to 1, we will get 1 upon log 1, right? But log 1 will be 0, so 1 upon 0, so we are getting infinity. Similarly, if we put x is equal to 1, 1 minus 1 will be 0. So again this also will go to infinity. So we are getting infinity minus infinity form. So we will take LCM first. So on taking LCM you will get limit x tends to 1, x minus 1 minus x log x upon x minus 1 log x. So what we have done, we have taken LCM. Now suppose if you put x tends to 1, you will get which form? 0 by 0 form. So now you can apply our L'Hopital's rule. That is, we have to do the derivative of numerator and denominator separately. So we will do the derivative. So derivative of x minus 1 will be equal to 1 minus, here apply your UV rule. So x as it is, derivative of log x will be 1 upon x plus log x as it is, derivative of x will be 1. Similarly, here to apply your UV rule. So keep log x as it is, derivative of x minus 1 will be 1 plus now keep x minus 1 as it is, derivative of log x will be 1 upon x. Now x and x gets cancelled out. 1 minus 1 will be equal to 0. So finally what will remain? Limit x tends to 1 minus log x upon log x plus x minus 1 into 1 upon x. Now we'll simplify this further by taking LCM. So take LCM of x. So you will get minus x log x upon x log x plus x minus 1. Now suppose if you put x tends to 1, you will get again 0 by 0 form. So again we have to apply L'Hopital's rule. So do the derivative again. So derivative of minus x log x by applying UV rule will be equal to, keep minus log x as it is, derivative of x will be 1. Now plus, keep what as it is, minus x as it is, and derivative of log x will be what? 1 upon x. Done? So finally what will remain? Minus log x, this x gets cancelled out, minus 1 upon. Now again apply UV rule in this, so you will get log x plus 1 plus 1. Simplify this further and put the limit. So on putting the limits, you will get value of the limit as minus 1 upon 2. Okay. Next, let us evaluate limit x tends to 0, 1 upon x square minus 1 upon sine square x. So let us start the solution. Firstly, we will assume the given limit as L. Now let us put the value of x as 0. So which form you will get? Infinity minus infinity. So now take your LCM. So on taking LCM, you will get limit x tends to 0, sine square x minus x square upon x square sine square x. Now if you put x is equal to 0, you will get 0 by 0 form. Now before applying L'Hopital's rule, we will multiply and divide by x square to make our sum easier. So on multiply and dividing, you will get this expression. Now we know limit x tends to 0, sin x upon x is equal to 1. So we will rearrange the term as sin square x minus x square upon x is to 4 into, take this over here, x square upon sin square x. Now the limit of this is 1. So what will remain? Limit x tends to 0, sin square x minus x square upon x raised to 4. Again on putting x tends to 0, you will get 0 by 0 form. So apply your L'Hopital's rule and do the derivative. So derivative of sin square x will be 2 sin x on applying chain rule into cos x minus 2x upon derivative of this will be equal to 4x cube. Okay. Now further simplification, you will get 2 sin x cos x will be equal to sin 2x minus 2x upon 4x cube. Again, if you put x tends to 0, you will get 0 by 0 form. Again, apply your L'Hopital's rule and do the derivatives. So that will be equal to 2 cos 2x minus 2 upon 12 x square. Again, if you put x tends to 0, similarly you are getting 0 by 0 form. Again, do the derivative, so you will get limit x tends to 0 minus 4 sin 2x upon 24x, right? Again, you are getting 0 by 0 form. So again, do the derivative, so you can get answer as minus 8 cos 2x upon 24. Now finally, if you put x tends to 0, we know the value of cos 0 is equal to 1. So you will get answer as minus 8 upon 24. On simplifying, you will get the value of the limit as minus 1 upon 3. So in today's session, we have studied two types of indeterminate forms. They are infinity by infinity and infinity minus infinity. Here you have to directly apply our L'Hopital's rule. The rule is what? Limit x tends to a, f of x upon g of x will be equal to limit x tends to a, f dash of x upon g dash of x, right? That is, you have to do the derivative of the numerator and denominator separately. Next, you have studied infinity minus infinity form. In this, firstly you have to take LCM or you have to rearrange terms. Rearrange the terms and convert it into 0 by 0 or infinity by infinity form and then apply our L'Hopital's rule. So I hope you understood both the indeterminate forms. Thank you for watching.